Warm greetings to the jury members. Have you ever spent hours writing complex PLC code only to find a simple logical error? Or maybe you have been handed a legacy project and spent days trying to reverse engineer the logic? Traditional PLC programming is a slow, error prone process. It's a communication gap between the human idea and the machine's code. We waste time on syntax debugging and documentation, which the time could be spent on innovation. We are here to bridge that gap with AutoCode AI, an AI powered PLC development tool that transforms your ideas into reliable control logic. This is our application, ABB PLC programming suite, and we have four options to specify the output format. One is structured text, second is ladder logic, third is functional block, fourth is sequential function chart. So on choosing any one of the options, and in the area of natural language input, you have to enter the prompt for which the code has to be outputted. So here we are giving control heater with PID loop to maintain temperature at 75 degrees Celsius using RTD sensor. Once clicking the generate button, the code starts to connect with the Olama which we have hosted on our local computer, and it would be raising an API query to the Olama model, and the model which we are using is 5.3 mini, which is developed by Microsoft, and we have precision tuned with our 500 set of datasets especially for PLC programming. On clicking the generate button, it implements the API call between our Olama model and the front end which we developed, and it gets the output as in the syntax of the structured text or whichever output format you have clicked, and the generated code will be automatically typed in the output area. Once the code has been outputted, we can see the validation of the code. Validation is the function which we are using to check if there is any syntax error in the generated code, or is there any errors or any warnings present in the code. This is done through automatic processing, which is powered by AI, and it shows the errors, warnings, source, logic, and the perfection rate of which the code is. Once the code is validated, you can edit the program on based on the suggestions given by our validation AI, and after finalizing the program, there is an option to export the program, and the export option is available in multiple formats. One is technical documentation, which integrates the PDF form, and there is also an option to generate it as an SVG. We can also include the generated source code, original natural language requirements, generation metadata and timestamp, inline code comments, and format conversion notes, also the code validation information in the document which we are exporting. Once successfully choosing all the options, we can click import, and the corresponding file with the respective file extension will be saved on our system, which can be viewed after completing the program and can be reviewed. Our solution also has an option to reverse engineering, and it has a text area to enter the structured text code. So by clicking the find reason button, our locally connected LLM will summarize the whole code, and it will give the details of the functions used and also on what this code is made for. So it will be enabling engineers to better understand the code, and it will help them to learn very much and also automate their processes too. Finally, this is our simulation tool, which is an industrial process simulation, and it has simulation control, virtual inputs, virtual outputs, and also the graphs of the plot between temperature, pressure. So we can mention the tank level, pressure, temperature, and there is options for start button, stop button, emergency stop, and also the automatic mode. And the input button show the LED indicators, and it also glows whenever the condition is set and whenever the requirements are met. So by clicking the start button, the pump motor gets on, and we could see the difference in the decreasing levels of water levels. And when the temperature rises above 40 to 50, the fan automatically turns on. And also when click emergency stop, the alarm gets on and the whole device process stops. So this is a basic introduction to a simulation. So this we can be implemented using the code whichever is generating, and it will automatically take the variables from the code whichever we generated. This is our ready prototype, which can be further implemented by connecting the real world machines into this using IoT, and the inputs and outputs connected to the current machine can automatically updated by in our software, so that it could be easier to code and it could automate the whole engineering process as well.